So each year, there's about 2 million burglaries. Of those, 2/3 are home break-ins. Our group has designed a better home surveillance camera system that implements incredible low-light recording, live video streaming, and body tracking, not motion tracking. My name is Silas Kurth, and I'm the group leader. I was in charge of creating documentation like PowerPoint presentations, Gantt charts, and reports. I also worked on the PID control for the motors and implemented a working prototype earlier in the semester using MATLAB.
I'm Roland Garcia. I'm double E major, and I led our AutoCAD design team and 3D printed all our mechanical component parts.
Hello, my name is Adrian Gassaro, and I was the power engineer, and I also did a lot of 3D design work.
Hello, I'm TheaterCisneros. I was in charge of the networking, and I was also in control of the microcontrollers, including an Arduino Nano to control 2 dimixel motors. That's the ones that are actually moving the entire assembly, and they are also controlled through OpenCV and C++, which
I'm Mohammed. I'm one of the programmers, and I was responsible for algorithm analysis and implementation. Essentially, I'm taking advantage of open source libraries and packages for computer vision that are available and adapting 3 detection and tracking algorithms so that not only do they work computationally efficiently, but also in a manner that our program is scalable. So we are using the NVIDIA Jetson as our core processing unit because of its really powerful GPU. And in addition, the Jetson allows us to scale up to 6 cameras per board. And speaking of cameras, we're using the Sony's ultra low light camera that allows us to maintain our level of high detection accuracy in low light or nighttime scenarios. So the program is designed so that it allows the developers to connect to it wirelessly and over time input more updated or replace or add machine trained cascades that the algorithm relies on for detection. And this not only allows us to improve the accuracy over time as we train more and more machine learned cascades, but it also allows us to expand the knowledge base of the camera so that it can detect beyond just bodies or faces, maybe license plates and so forth as required, right? And the way the tracking component of it works is by allowing the program to communicate with the Arduino, and that is connected to 2 dynamixel motors, and those dynamixel motors essentially are fine-tuned using PID controls and the Ziegler-Nichols method so that our motion is not only speedy but also smooth. And yeah, any questions at this?
Can you talk about the range of motion and also the size of the object being tracked? Because I have a ring in the other day. I was telling there's someone moving because it was raining heavy.
Right.
There was nothing. So that's my second question. How big that object has to be tracked, and also what's the range of motion?
So the range of motion, we've got a working prototype that's in the other senior design building that is mounted, and its range of motion, and all of our products' range of motion is essentially 180 degrees sideways and about 165 degrees up and down, right? And the range of detection, that has been adjusted because we are, at least for our prototype, we are assuming that it's going to be mounted on the edge of like a house's corner. So we need to be able to see a person approaching. So we've adjusted the parameters so that really, I can't recall the numbers off the top of my head, but at the edge of your lawn, and then continue tracking that person until they're like maybe right under the camera, try to break into through your window or whatever.
So the second question, how big the object has to be tracked?
Essentially, the object's detection size is dynamically resized depending on its distance from the camera. Yes, sir.
Do you adjust the focus length of the camera, or is it fixed focus length and you just have a wide angle all the time?
Fixed focus length, and we have a wide angle. Mechanically, we haven't been able to like adjust the focus of the camera that's mounted on the Jetson.
But it has a very large depth of field.
So yeah. Depth of field. So, but do you actually move the camera, or you just leave the camera? You're just
Yes,
tracking?
the camera is moving with the person walking.
Right. Yeah.
So as long as the person hits your field initially, then you can track it. If the person's out of the field, you won't be able to see it no matter what, basically.
Right, but the Jetson does allow us to add additional cameras, and the program can prioritize and send information to a camera that it has left my field of vision. Now this other camera should continue tracking it.
Can you differentiate between, say, a large dog and a person?
Yes.
Yes.
Yeah. large dogs, like leaves blowing in the wind, whatever. Yeah.
What about sunlight?
I think our camera is able to filter out like glare and sunlight.
No, not your camera. Do you have anything that filters out sunlight?
The program.
Changes in it?
I believe.
A cloud going across.
I mean, they mess up, most systems don't work.
Interesting. Now, since our camera, at least the prototype that's mounted, it's facing like straight and down at the lawn, it doesn't essentially get affected by the sunlight that's hitting it from
So
the top.
you have a shield?
Right,
Yes.
yeah.
Mechanical shield?
yeah.
Okay.
So we'll thank the team right now.
Oh, thank you.